All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm up number 61 is on the screen. Number 1 reads graph f of x equals 1 over x. Number 2 reads graph f of x equals x cubed. Then transform using g of x equals 2 times f of parentheses x minus 4, close parentheses, minus 3. Number 3 reads factor. Part A is x cubed plus 2x squared minus 4x minus 8. Part B is 5x squared plus 7x plus 2. Number 4 reads divide the polynomial with synthetic division. Polynomials given are x cubed plus x squared plus 5x plus 7 divided by x plus 2. And number 5, solve the quadratic equation y equals x squared minus 5x minus 24. Let's see how you do with that. I'll give you guys some time. Ready, copy, and go. All right. So by now you should be done with the warm-up. Let's see what we got. Number 1, it says graph. So your graph should look something like this. Right here. And right there. Something like that, yeah? And you made a table, yes? Let's see. Does your table look like mine? Let's see. Over here, I'll do that over here. There you go. Let me label it. Table. Is that pretty clear? Yeah. Anyways, you guys know what to do with the table, right? Anyways, let's go to number 2. Number 2, let me graph that up here. All right. Okay, Mr. Q. Yeah. Man, guys, I'm telling you, I'm trying to do my best to prepare you guys so you guys can get a career that you guys love to do. Like, I love this stuff. It's like, I have so much fun. So here's a cubic. There it is. And H and K, or 4, -3 is our vertex, which is somewhere over here. However, what does this 2 do to the entire function, being that it's A? What does that do to the entire function? Mia, what does that 2 do to the entire function?
Stretches it?
It stretches it. That is correct. Bam. Like so. So I'm going to graph that over here now that I have the vertex somewhere over here. So there it is. It's stretched. Very good. All right. Number 3, factors. What'd you get for number 3? Factors of number 3. Anthony, factors.
X squared minus 4 and x plus 2.
Thank you. So far, so good. However, look up, guys, whenever you have a binomial with a subtraction like this, and it has a square or an even number exponent, see if you can take the square root of both terms. And if you can, x and x, square root of 4 is +2 and -2, then you can. This is a difference of squares. That's why we are able to factor it again and bring down the x plus 4 to my factors. Factors of 3b. 3b should have gotten x plus 1 and (5x plus 2). Is that correct? Yes, okay. Number 4. Number 4, here goes for the purpose of going over the process one more time. I start with -2. Coefficients are 1, 1, 5, 7. 1, -2, -1, 2, 7, -14, -7. There's a remainder. So this is x squared minus x plus 7 minus 7, which is the remainder over x plus 2. Today, guys, we're going to be doing a bunch of this and really fast. So hopefully all the practice that we've been getting, now you're ready to go and you build up some wrist muscle. Does everybody have some wrist muscle already built? Yes? Yes, Mr. Q. All right, good. And last but not least, we solve for the equation, set it equal to 0, x squared minus 5x minus 24. It's a trinomial, negative 24 on the top and negative 5 on the bottom. Factors of negative 24 that add up to negative 5. That's negative 8 times 3. Set them equal to 0. And then set each one equal to 0. So at the end, we get x equals 8 and x equals negative 3. Those are my zeros, my solutions, my roots, my x-intercepts. All right, we good? Yes, Mr. Q. All right, good. All right. Our objective for today, our agenda for today is warm-up number 61. Today, we're still focusing on polynomial equations and zeros. Today, we're still graphing. Today's gonna get a little more complex. Your home play for tonight is pages 363 and 364. Pages 363, 364, all only. And notice that every time that we write like only, it makes it seem like very little, right? That helps us kind of like do the home play completely, right? Only. All right, let's lock this session. All right. So, y'all ready? Yes. Okay, here we go. Our asynchronous code. Write this down, XI7EC, XI7EC, XI7EC. Okay? So your previous home play was pages 348, 349, numbers 1 through 12 with the graphs. So go ahead and turn that in on Canvas. And hopefully by now, this time of the school year, I remember at the beginning of the school year, I said, well, you need to do every day since we're doing everything distance learning. Everything that you do, take pictures of everything when you're done with it. So like that, when you get to the class, you already have everything in the electronic format and you just submit it. It's 10 seconds, right? 20 seconds tops. Well, some of you that still have like the chisel and the rock and doing everything like that might take you like forever. Does everybody, you guys, my mic working? Yeah. Just, you get that chisel and rock? Huh? You know what I'm talking about? No? Like cavemen, like no technology. Anyways, so you're turning that in. Once again, your home play for tonight, pages 364. And I'll give you guys 30 more seconds to turn that in, and we'll get started right away. Get your Cornell note ready. You do need a FAIR model, and we'll get started right away. Copy that and go. All right. Well, now that we're back, here we go. Our objective for today, I can identify rational and complex zeros of polynomial equations. You're like, oh, snap, Mr. Q. Oh, snap is right. We've been working with identifying rational zeros of polynomial equations, but today we're adding what? Complex zeros. So does that mean it's going to get complex, Mr. Q? Oh, yes. Get it? It's going to get complex. You guys catch up? Yeah, you got it? Yeah. Okay. So in your FAIR model, polynomial equations, fill that in by yourself. Set it up. You can fill it in later just to keep our session going, because you are going to need to turn that in asynchronously. Once again, you need a definition, one example, one non-example. So where have we been with this? Why, I clarified what zeros were. We said that zeros are any number that can be substituted into the function that makes the function 0. Rational numbers are numbers that can be written as a fraction. So then what is a rational zero? It's a number that can be written as a fraction that can be substituted into the function that makes the function 0. You're like, that makes sense, Mr. Q. I know, right? And then we covered the rational zeros theorem. And I said, don't write that down because it's confusing. And all it says is that if you are given a polynomial function, you take the constant divided by the leading coefficient, you write all its factors, plus or minus, and any of those factors could be some of the rational zeros of the equation. So far, so good, yes? Yes, Mr. Q. All right, and then we did some practice on those and so on and so forth. Now, let me take you back to day 1 of this school year. Ready? Remember when you were baby, Algebra 2, Q, Mr. Q's class students, day one? And I said, okay, guys, this year's gonna be packed with stuff. And let's start with the basics, real numbers. I said, what are real numbers? I said, real numbers are broken into two categories, rational and irrational. You guys remember that? Yeah? They're like, oh yeah, like it was yesterday. Rational numbers, we already know the definition is that they can be written as fractions. However, rational numbers can be broken down into three categories. I said, we always started, when we started our lives in the world and we started with numbers, we always started with what? Counting numbers. Remember when you used to race in preschool or kinder? A lot of people, I'll race you to the swings. You get there and you go, he can go higher. And when you started counting, right? -1, -2. No, you didn't count in negatives. We counted what? 1, 2, 3. Those are known as counting numbers, also known as natural numbers, because they're natural to count. From there, the next category is known as whole numbers. What are whole numbers? Well, they are counting numbers, but including 0. So all of these, but now including 0. And the last category of rationals are known as integers. What are integers? Well, the previous ones, all the whole numbers, but including their opposites. So now it's going to include all the negatives. All right, so all these are rational. What are irrational, Mr. Q? Well, these are all numbers that can be written as fractions. That means irrationals are numbers that cannot be written as fractions, such as square root of pi, square root of 2, phi, and e. You guys remember that? Yeah, some of you? Yes, Mr. Q. And then I said, okay, guys, well, if all these are real numbers, what do we call numbers that are not real? That are not real? Well, imaginary. And you're like, man, that makes total sense. I know, right? So, and what example did I give you guys? Square root of -16. And I said, keep this in mind. Whenever you get a square root of a -1, that's the letter I, known as imaginary. But if I gave you -1, I'm sorry, square root of -16, we can extract the -1, which is I, and square root of 16 is 4. So that means this is what? 4i. Okay. And then I said, guys, whenever we get towards the middle of the course or towards the end, we're going to combine these two, and it's going to create a new category known as complex numbers. Guys, remember that? So it's made up of a real number and an imaginary number. So that's what we're going to be talking about today. Okay. So here we go. Start with some practice. I want to practice some that I left you for home play last night and see how you do. Copy this one. Example 1. Find the zeros of the polynomial function and graph f of x equals x to the 4th plus 3x cubed minus 4x squared minus 12x. It's going to go pretty fast, so everybody go like this. Look at the screen. Bear with me. It's going to go fast. I'm just letting you know, those of you that are multitasking. Ivan, stop it. Stay focused. Please, pretty please. All right, here we go. So, according to what we did last night, you saw that some of them didn't have constants. So when they don't have constants, what did I ask you to do? Check for what? GCF. Is there a GCF for all terms? Yes, x. And that leaves us with x cubed plus 3x squared minus 4x minus 12. And now that we have a constant, so this -12 is going to be our constant, -12. And what is our leading coefficient? An invisible 1. There it is. So this is -12. So we need to find all factors of 12, positive and negative. Let's start. 1 times 12, 2 times 6, 3 times 4. All of these are factors of 12, plus minus, and any of those could be our 0. But this is for just this inside, not the x outside, and not this one over here. It's just for what's inside. So I'm going to write all my coefficients and constants for this one, which is 1, 3, -4, -12. And I'm going to start with +1. +1 as my divisor. Okay, here we go. It's going to go pretty quick, so stay focused. 1 times 1 is 1, combined that's 4. 1 times 4 is 4, combined that's 0. 1 times 0 is 0, combined that's -12. and that's not our 0. Let's go to -1, 1, 3, -1 times 1 is -1, combined that's 2. -1 times 2, that's -2, combined that's -6. 1 times -6, that's 6, combined that's -6. This is not our 0. Let's go to the next one. Let's switch to blue. I'm going to do +2, +2. 2 times 1 is 2, combined that's 5. 2 times 5 is 10, combined that's 6. 2 times 6 is 12, combined that's 0. This is our 0, 0. All right, so how do we write that 0? So according to what we did in the past, that +2 becomes x minus 2. What do we have left? So this was a cubic. That means this is a squared. So this is x squared plus 5x plus 6. Now, before I factor more, I'm gonna not forget, look up. Don't forget your GCF over here. Make sure you write it right there. Okay? So now we have a trinomial. We still need to factor that if we can. So let's try. I'm gonna use green. Factors of 6 that add up to 5. What two numbers multiply to give us 6 and add up to 5? 2 and 3. 2 times 3 is 6. 2 plus 3 is 5. Since this x squared doesn't have a leading coefficient, I can break it up into x and x. My two numbers are +2, +3. Bring down the x minus 2 and bring down the GCF, which was x, and all that equal to our function f of x. All right, we did that 2 sessions ago, or the previous session before we went out to break. But then I said, now we need to graph, guys. So what do? We need to find our zeros. These are our factors, so we set it up to 0, x, x minus 2, x plus 2, and x plus 3. Set each one equal to 0, x equal to 0, x minus 2 equal to 0, x plus 1 equal to 0, oh, x plus 2, I'm sorry, not 1, and x plus 3 equal to 0. Let's solve. This one's already solved. +2 plus 2, x equals 2, minus 2 minus 2, x equals -2, minus 3 minus 3, x equals -3. All right, and what are these called, guys? These are my solutions, because we just solved for x. They're also known as roots, x-intercepts for our graphing purposes, x-intercepts, and also our zeros. Why are they called zeros? Because if we substitute them into the original equation, we get 0. Okay, so let's graph. I'm going to do the coordinate plane right here, small one. So now, according to what we covered in our last session, I said we should know by looking at the function where the graph starts and where does it end. Yes? Yes, Mr. Q. According to the power of that polynomial equation. So look up. What is the greatest power of this polynomial equation? The greatest power is 4. It's an even number. So that means what? It's going to start in quadrant 2, and it ends where? In quadrant 1. It starts where? Quadrant 2, and ends quadrant 1. So let's plot our x-intercepts. What are x-intercepts? 0, there it is. 2, there it is. -2, there it is. And -3. All right, so if we're going from left to right and we start up on the second quadrant and then over here, this is what it's going to look like. I'm going to start over here and you should go through each of these. So here we go. And there you go. Let's go. Does that seem familiar? Yes, Mr. Q. I love these. All right, good. So let me give you another one for you to do by yourself. Ready? Example. Ooh, let's go. Oh, yes. It's going to be packed today. Copy this one. Example 1Q. It says find the zeros of polynomials of the polynomial function graph. G of x equals x to the fourth plus 2x cubed minus 9x squared minus 18x. Very similar to the one we just did. I'll give you some time, copy that and go. All right, let's see how we did. So what did you guys notice? There's no constant, so you should have checked for GCF, and the GCF is x, so we're left with x cubed plus 2x squared minus 9x minus 18. And from there, now we have negative 18 over 1, which is negative 18. Factors of negative 18 plus and minus were 1 times 18, 2 times 9, 3 times 6. And I think that's it, right? Yes, thank you. All right. So then let's start with positive 1. So you should have done positive 1, 1, 2, negative 9, negative 18. 1 times 1 is 1, combine that's 3. 1 times 3 is 3, combine that's negative 6. 1 times negative 6, combine that's negative 24, and that's not our 0. Let's try negative 1. Negative 1 times 1 is negative 1, combine that's 1. Negative 1 times 1 is negative 1, combine that's negative 10. Negative 1 times negative 10 is 10, combine that's negative 8. That's not our 0. Next, let's try 2. 2 times 1 is 2, combine that's 4. 2 times 4 is 8, combine that's negative 1. 2 times negative 1 is negative 2, combine that's negative 20, and that's not our 0. Let's try negative 2. Some of you are like, man, Ashiki, how can you do that so fast? Let me show you. Negative 2 times 1 is negative 2, combine that's 0. Negative 2 times 0 is 0, combine that's negative 9. Negative 2 times negative 9 is 18, and that's our 0. 0. Okay, how do I write that 0 if it's a negative 2? So it's written as x plus 2. What do we have left? If this was a x cubed, that means this is an x squared, so I'm left with x squared. This is a 0, so no x, and that's a constant of negative 9. Before I finish the next step, don't forget your GCF. What was our GCF? X. Now, look at the last factor. Does this look familiar? Adding. What can I do with this factor?
With that one, can't you do the thing where you make it x minus 3x plus 3?
That is correct. This is a difference of squares. It's a difference. Let's see if we can take the square root of both x and x. Yes. Square root of 9 is positive 3, negative 3. Bring down the x plus 2 and bring down the x. And all that equal to g of x. However, they want us to graph. That means we need to find our zeros. How do we do that? We set it equal to 0. X plus 2, x plus 3, and x minus 3. All right, so x equal to 0. That's already solved. X plus 2 equal to 0, minus 2 minus 2. X equals negative 2. X plus 3 equal to 0, minus 3 minus 3. X equals negative 3. And x minus 3 equal to 0, plus 3 plus 3. X equals 3. Okay, so now that we have our zeros and our x-intercepts, solutions, roots, let's graph. Here's our coordinate plane. And by looking at the original polynomial equation, what's the highest degree, guys? Show me with fingers. Highest degree is, I see you, 4, yes, 4. It's right here. So if it's an even number exponent, it starts on quadrant 2. And where does it end? In quadrant 1 over here. So let's plot our x-intercepts. X-intercept 0, x-intercept negative 2, x-intercept negative 3, x-intercept 3. So if we start over here on quadrant 2, we go through the first one from left to right, next one, and next one. Look at that. It's beautiful. That's like, no, it's not a Picasso. This is like a Q-Casso. Q-Casso? Bam. Yeah, Q merch. That one on a shirt. How about that, Apple? Yeah. Okay, let's do another one. Copy this next one. Example Q. F of x equals x squared plus 2x minus 8. Same instructions. Let's do this one together. It's going to go pretty fast. Here we go. It says find the zeros of the polynomial function and graph. F of x equals x squared plus 2x minus 8. You're like, Mr. Q, this one isn't like a big polynomial. Do I still need to do the constant and the rational zero theorem? Not necessarily. It's a trinomial. What can we do here? Find our factors. What do you think, Hayden? What can I do to find my factors?
Can't you just do the x thing?
Yes, the x thing, negative 8 and 2. Factors of negative 8 that add up to 2, that's 4 times negative 2. So let's factor the x, becomes x times x plus 4 minus 2, and all that equal to f of x. Now, could we end up with this if we did the synthetic division? Yeah, some of you love the synthetic division, so you could have done that. That's fine. But let's continue. We need to find the zeros, yes? So 0 equals x plus 4, x minus 2. So let's set each one equal to 0. So we got x plus 4 equal to 0, x minus 2 equal to 0. So minus 4 minus 4, x equals negative 4, plus 2 plus 2, x equals 2. All right, so these are my x-intercepts zeros. I'm going to graph over here. So look at the polynomial equation. What's the highest degree, guys? The highest degree is 2, which is an even one. So where does it start? Where does the graph start? In quadrant 2. Where does it end? In quadrant 1. Okay, so what are my x-intercepts? X-intercepts are negative 4 and positive 2. However, look up to the screen really quick. Look up. Look up. Now, for those of you that were with me since 8th grade, by now you should know this. Those of you that haven't been with me for a while, hopefully you caught on throughout the year that I've been hammering this. Look at the constant. What is our constant? Negative 8. What is that on a graph of a quadratic equation? Let's see if you remember. Let me put somebody on the spot. What do I put on the spot? Let's do, how about Mia? What is negative 8 on the graph? Known as? Yes. Yes, say it.
The y place? The like.
Yes, the white place, the y-intercept. So I'm gonna place it down here. Bam, Mia in the house. Yes. So any function, guys, that is given, if it's in standard form, the constant will be where the graph crosses the y-axis. So here, if we go from left to right, starting here, needs to go through the y-intercept and through the other route. There it is. Ooh, let's go. Man, this is too easy. Man, this is like preschool stuff. All right, let me give you another one for you to do by yourself. Here we go. Example, mega q, f of x equals x squared plus 2x minus 3. See how you do with that one. Ready, and copy and go. All right, should be just about done by now. So let's see. Some of you use the constant and the leading coefficients to create all your factors, and you're doing the synthetic division, but I'm going to start with power range. Negative 3 and 2 down here. Factors of negative 3 that add up to 2, so that's 3 times negative 1. 3 times negative 1 is negative 3. 3 plus negative 1 is 2. So I need to factor this x, that is x squared is x of x, plus 3 minus 1, all that equal to f of x. But since we're graphing, now we need to set it equal to 0. We have x plus 3 and x minus 1. And then we set each one of these equal to 0, x plus 3 equal to 0, x minus 1 equal to 0. So minus 3 minus 3, x equals negative 3. plus 1 plus 1, x equals 1. And our graph, let's see, we have our first, where does it start, where does it end? It's an even number exponent, so it starts on quadrant 2 and quadrant 1. So our x-intercepts are -3, +1. And what's our y-intercept, everyone? Show me the fingers. Yeah, I see you guys doing this and this. Stop throwing signs. So it's -3, -3. There it is. So yes, so we go from left to right. There it is. All right. From 1 to 5, how come you are so far with us? I see some 5s, 5, 5, 5, 4s, 5 4s. Yes, 5 4s. Okay. Do another one. Copy this one. Example, super cube. F of x equals x cubed plus 6x squared plus 5x. And let's do this one together to not waste any time. Here we go. And same instructions, you need to write the instructions again. However, wait a minute, Mr. Q, wait a minute. Trinomial, but there's no constant. So what do I do, Anthony?
Find the GCF.
GCF. So what is the same in all terms? X, and we're left with x squared plus 6x plus 5. All right. So can we factor the inside? Yes, it's a trinomial. So I'm gonna go. Do you guys want to do the whole synthetic division or Power Rangers? What do you guys think?
Power Rangers.
Yeah, Power Rangers. 5, 6. So factors of 5 that add up to 6. 5 times 1 is 5. 5 plus 1 is 6. So x squared becomes x times x. And then we have plus 5 and plus 1. Bring down the GCF, which is x, and all that equal to f of x. All right, so now let's solve. So we need to set it equal to what? 0. X plus 5, x plus 1. So we set each one equal to 0, x equal to 0, x plus 5 equal to 0, x plus 1 equal to 0. So minus 5, x equals -5, minus 1, x equals -1. All right, so those are my x-intercepts, roots, solutions, zeros. So before I graph, look up, guys. What do we need to know? Where does it start? Where does it end? What kind of power does it have? It's an odd number. So where does it start? On quadrant. Very good. Yes. Quadrant 3. My goodness. And where does it end? In quadrant 1. So I don't know if you guys notice right now, they're all ending in quadrant 1. Yeah. So you just need to worry about if it's odd, it starts in 3. If it's even, it starts in 2. All right. So let's graph our x-intercepts. 0, -1, and -5. So if we start here and then over here, let's see, go through the first one from left to right, second, and the third. There it is. Look at that. Beautiful. All right, let's do another one. Ready? You do the next one by yourself. Here we go. Example, Shazam cube. Same instructions. F of x equals x cubed minus 8x squared plus 7x. I'll give you some time. Copy that and go. All right, very similar to the one we just did. There's no constant, so we check for GCF. GCF is x. We're left with x squared minus 8x plus 7. It's a trinomial. 7 on top, -8 on the bottom. Factors of 7 that add up to -8. That's -1 times -7. So x squared becomes x and x. -1 minus 7 because of those two. Bring down the GCF, and all that equals to f of x. We need to solve, so we need to set it equal to 0. X minus 1, and x minus 7. Set each one equal to 0. X equal to 0. X minus 1 equal to 0. Why did I put this parenthesis there? Plus 1 plus 1. X equals 1. X minus 7 equal to 0. Plus 7 plus 7. X equals 7. So now that we have our x-intercept, let's graph. Here we go. Let's check where we start. It's an odd number exponent, so we start in quadrant 3. Where do we end? In quadrant 1. My x-intercepts are 0, 1, and 7. All right, from left to right, starting from quadrant 3, up, down, and up. There it is. And there's my function. Woo! I love these. Let's go. Let's go. All right. A polls on your screen from 1 to 5. How comfortable do you feel so far? We've been doing this. You did this for your own practice overnight. Hopefully this helped get you guys there because we're about to get into more complex stuff. I'm just walking you guys in. Ready? So we got 5, 5, 5, 5, 5, 5, 4, 5, 4, 5, 4, 5, 5, 5, 4, and 1, 3. Once again, if you need more practice, guys, today at 1:15 tutoring, be there or be elsewhere. Also at 2 o'clock, if you want to join us for the home play that was assigned for the break, Easter break, so you can get practice on the process. Be with us at 2, okay? Yes, Mr. Q. All right. So with that said, y'all ready to rank it up a notch? Copy this one. Example super duper cute. Copy that. F of x equals x cubed plus 2x squared plus 3x. All right. So there's no constant. So what do? Just ZL.
You have to find the GCF.
GCF, which is x. So we're left with x squared plus 2x plus 3. All right, now we can factor that. So I'm going to do the 3 goes on top, 2 goes in the bottom. Factors of 3 that add up to 2. Factors of 3 that add up to 2. What do you think, Octavio? What 2 numbers multiply to give me 3 that when you add them give us positive 2?
-1 and -3.
-1, -3. So if we do -1 and -3, that's -4. What do you think, Esmeralda? You're like,
I don't think there's any.
there is none. Thank you, Esmeralda. There is no factors. What? So you're like, Mr. Q, so what do we do with a quadratic that we cannot factor? Who remembers? Very good. So this quadratic that we cannot factor, but we need factors, we use minus b plus minus square root b squared minus 4ac over 2a. Some of you are like, Mr. Q, that's my favorite, right? That's funny. Some of you are mouthing, nope. Okay, be nice. Negative parentheses plus minus square root parentheses squared minus 4 parentheses over 2 parentheses. So that means we need values for A, B, and C. So by looking at this, hopefully you can see the values of A, B, and C. Does everybody see what I'm talking about? For those of you that don't see, let's see. Let me write it underneath the standard form. AX squared plus BX plus C. So now that you have that, you have values, yes? So what is A? A is an invisible 1, and it goes right here and right here. What is B? It's 2, there and there. And what's C? 3. All right, let's simplify. So this is -2 plus minus square root. 2 squared is 4. -4 times 1 times 3, that's -12 over 2. Next, simplify. -2 plus minus square root of -8 over 2. You're like, what? Now look up, guys. What do you guys notice on the radical? Well, before that, let me go to the side over here. If we were to be solving a quadratic equation, we would have to write two equations, right? Yeah, one for the positive and one for the negative. So I would write -2 plus square root of -8/2 and -2 minus square root of -8/2. All right. Question. Look up. Do you guys notice something? And I'm going to be obvious here. Here. Yeah. It's a negative square root. What is the negative square root? And I'm going to write it here. Negative square root. What is that called whenever we have negative square roots? Yes. Imaginary, which means these cannot be graphed because these are what? Complex zeros. Okay. However, don't forget the other one. What is the other one, guys? Look up. Bring down x. Let's set it equal to 0. This one is a rational zero. These are known as complex zeros because if we put them equal to 0 and it's a complex number, it's a complex zero. Can we graph them? No, because now we have two different types of numbers there. So when you get to these, make sure you just write them as complex zeros and rational. Just let me know what you have. Like that I understand that you understand that I understand that you understand. Do you understand? Yeah? All right. It's another one. Ready? Here we go. This next one's going to go pretty fast. Copy this one. Example, q of x equals x to the fourth times, x to the fourth plus 4x cubed plus 13x squared plus 36x plus 36. So here we go. We got 36 over 1, which is 36. So factors of 36 plus minus are 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So all of those. And this is one of those that you have to do a lot of the work, but I'm going to be nice. And I'm going to start us off with, let's try -2. -2. Start off with -2. So my coefficients are 1, 4, 13, 36, 36. Here we go. -2 times 1, that's -2. Combined, that's 2. -2 times 2, that's -4. Combined, that's 9. -2 times 9, -18. Combined, that's 18. -2 times 18, that's -36. And that's our 0. So we write it as x plus 2. What do we have left? X cubed plus 2x squared plus 9x plus 18. You're like, Mr. Q, we have to do it again. I know. However, look up. C, instead of doing the next, synthetic division, see if you can actually group it and factor it and see what it gives you. Here he goes. Group, group. What's GCF here? X squared, and that leaves me with x plus 2. What's GCF here? 9, that leaves us with x plus 2. Oh, it does work. So what's the same here and here? X plus 2 and x squared plus 9. Don't forget to bring down the original 0, x plus 2, and all that equal to q of x. Now they want us to graph, so we need to set it equal to 0. X plus 2, x plus 2, and x squared plus 9. So x plus 2 equal to 0, minus 2 minus 2, x equals -2. Write it again, x plus 2 equal to 0. What are we going to get again? X equals -2. This is known as, we called it duplicity. I'm going to call it, like the book calls it, multiplicity. because it's a multiplier of the same one. And this one we write as x squared plus 9. Can we solve this? Yes, minus 9, x squared equals negative 9. How do we cancel that squared? Square root, x equals plus minus. What is square root of negative 9?
3i.
3i. And what do you know? This is a complex 0. There's two of them, a positive and a negative. And over here we have a what? A rational 0. You're like, and that's all we do? That's all you do. You don't have to graph it. You don't have to do anything else. Once you get to the point where you find a complex 0, you stop right there. Okay? Last problem. Ready? Here we go. So you're going to get some of these where they're going to ask you to write a polynomial equation given the zeros. You're like, what? So watch. They give us 3 zeros here. Look up to the screen. They give us 5 and 3 plus 2 square root of 7. You're like, Mr. Q, I only see 2. Well, let me show you. Look up. The first 0 is 5, so I write it as x equals 5. The next 0 is x equals what? 3 plus 2 square root of 7. And let me show you the other 0. X equals 3 minus 2 square root of 7. Why did I do that, guys? Because it's a what? A square root. So whenever you get, look up, guys, whenever you have, they give you a 0 that's a square root or an imaginary number, make sure you do one positive and one negative. So that means there's 2 of them, okay? All right, so we need to write our equation or our function given the 0. So look, I need to set this equal to 0. So once you have it like that, you need to set it equal to 0. So minus 5, x minus 5 equal to 0. I'll stop there. Look at this one. Minus 3 plus 2 square root of 7 minus 3 plus 2 square root of 7. So now it's equal to 0. So it's x minus 3 plus 2 square root of 7. Let me do that for this one as well. Minus 3 minus 2 square root of 7 minus 3 minus 2 square root of 7. We're left 0 equals an x minus 3 minus 2 square root of 7. Are we there so far? Yes, Mr. Q. And pretty much we're done. We just need to write our function. Look up. F of x equals, what's this binomial? Oh, I write it as a factor, x minus 5. What's this binomial? X minus 3 plus 2 square root of 7. What's this binomial? X minus 3 minus 2 square root of 7. And this is my function. That is as much as I want you to do for tonight's homework when you get to those. So if you notice, we basically just went backwards. Do you guys notice that? We started with zeros, just a number. We set it equal to x, and then we set it equal to 0 by isolating the x and whatever number was with it. And that's how we are able to write our factors, okay? So I'm gonna stop right there. You're gonna get plenty of practice tonight. Once again, tutoring at 1:15 if you wanna go over this home play. If you wanna join us at 2, we're gonna go over the home play from the Easter break. Okay, guys, I hope this did you well. Let me send you a quick poll really quick before we log out. From 1 to 5, how comfortable you feel with everything we saw today? 1 to 5. 5 fours, 5 fours, 5 fours, 5 fours, 4 4 4 4 fours, 5 fours, 5 fours, a couple of threes. And yeah, we just need practice, yeah? Yes, Mr. Q. All right. So once again, make sure if you need the extra support, be there in tutoring, be there or be elsewhere. All right. Have a good one, guys. It was nice seeing you. Peace.